So remember, when we're finding domains, we've got these three, at this point, we've got these three situations here. We've got an even index radical, a variable in the denominator, and then we've got various combinations. So remember, for the even index radical, our concern is that what's inside the radical never be a negative, because if we try to take the square root of a negative, we get a non-real number. So you have to take whatever inside the radical, set it greater than or equal to 0, and you get, in this case, x greater than or equal to 1/2. Interval notation would be 1/2 to infinity, like that. Now, another situation is when we have a variable in the denominator. Now our concern is that we not try to divide by 0. That's our concern. Okay, so we have to, when we're talking about the domain, we say, okay, 5x minus 2 in this case can never be 0. Or another way to say that is x can't be 2/5. See? Now, if you wanted to write that in interval notation, negative infinity to infinity would be all real numbers. But we're going negative infinity, almost to infinity, but we're skipping over 2/5. So we're going right up to 2/5. And then carefully stepping over it and going on to infinity. So those are the two main parts of finding the domain, the two cases. Then we have the combinations, like this one. Okay? Now here we have the radical, 2x plus 3. It has to be greater than or equal to 0. And also 5x minus 2 can't be equal to 0. These are the two conditions that we've got to be sure exist here. We can't plug in any x's that violate either one of these. In other words, x has to be greater than or equal to negative 3/2, and x cannot equal 2/5. Those are the two conditions that have to be met. If an x wants to be part of the domain, it has to meet those two conditions. So here's what happens. We're going, first of all, we're starting here at negative 3/2, and we're going to 2/5. Skipping over 2/5 and going on to infinity. Okay, now let's look at the difference quotient. When it comes to simplifying the difference quotient, we're going to have pretty much these three types of problems. We've got this, this little basic, polynomial here where we just have, something squared, a quadratic. Then we're going to have a radical like this, a square root, and we'll have a rational function. So there's a trick for each one of these. And what we need to do is know how to address each one of these. First of all, for this one, we just set up the difference quotient. We just say, okay, f of x plus h. And the tendency is, if you're going to make a mistake here, you might leave off the 6. Sometimes people do that. But so beware, be sure you get it all in there, and then minus, and then another mistake might come when you forget to put the whole function in the parentheses. Then you put it over h. So notice, we've got f of x plus h minus f of x all over h. Okay? Then we need to multiply everything out, clear those parentheses, and see things start to cancel. Okay? So this first thing, x squared plus 2xh plus h squared. Now, some people, it's easy to make this mistake. In multiplying out the x plus 8, sometimes there's a tendency to call that x squared plus 8 squared. But just remember, you're foiling that out. You're multiplying it using distributivity. So that's x squared plus 2xh plus 8 squared. And then we clear the parentheses here. Yeah. And then we've got the minus 6. Don't forget the minus 6. It's easy to forget that one as we're going through here clearing these parentheses. And then we drop the parentheses over here, changing all the signs inside. Yeah. Now, the cool thing is, we get some cancellations here. And when you're working a problem like this, if things don't cancel like this, you just can realize, okay, I probably made a sign error somewhere. I forgot my parentheses over here, something like that, because you should get some major cancellations going on. Okay? Now let's see what we've got. Let me move this down a tad. There we go. So now let's see what we've got. Whoops. Okay. We've got 2xh plus h squared minus 5h. There we go. Man, that's a lot simpler, right? Factor out the h. And there we have it, 2x plus h minus 5. So that's as far as we go in this class. Okay? Like I've said, we're getting set up for calculus when we're going to go further than this, but this is as far as we're going right now. We're just getting to where that h is out of the denominator. Okay? Now let's look at this next one, where we've got a square root. So we still set up the difference quotient the same way, replacing x with x plus h. There. So we got the first step done. When we can write x plus h, f of x plus h minus f of x over h. First step. Good. And really, it's just a matter of getting each step correct. Right? Now, the trick, with the other one, all we did was multiply out. Terms canceled. Here we've got a trick. With this one, the trick is we multiply by the conjugate on the top and the bottom. Top and the bottom. Remember, you got to do it to both, because then it's just like multiplying by 1. Now, the reason we did that is because a minus b times a plus b is a squared minus b squared. So what happens is these radicals, we get rid of them. Be careful to put the whole x plus 3 inside the parentheses. Okay? Because the minus is in front of the whole thing. And then we get h times there we go. And our trick worked because you notice lots of things start to cancel. We've got x plus h plus 3, but when we drop the parentheses, we've got minus x minus 3. There we go. Yeah, and things cancel here. Look at this. Dig it. All right. That's what we wanted. Because now notice these h's will divide out and I just have a 1 up top. So let's see what we've got here. We've got 1 over the square root of x plus h plus 3 plus the square root of x plus 3. And there we have it. Okay. So that's the second type, where we have the square root. And the trick is multiply by the conjugate. Okay. Now here's the third type. Okay, where we have this rational function. We set up the difference quotient just like always. There it goes. There's the difference quotient. But the problem with this one is we've got this denominator, these extra denominators. We've got a numerator, denominator, but in the numerator there's these denominators, right? So what I need to do is I need to multiply by the product of these denominators. Okay? In other words, I need to multiply by x plus 4 times x plus h plus 4. If I do that, that's going to divide out those extra denominators and I won't have to worry about them anymore. So let's see what I've got here. Okay, so here it goes. Okay, there's the first term. Minus there's the second. And then down here, I've got to do the bottom as well. Yeah, there it goes. So really, we just multiplied the top and the bottom by x plus 4 times x plus h plus 4. It's just like multiplying the whole thing by 1. And the reason we did that is so that this would happen. Woohoo! Look at that. We got rid of those extra denominators. Those things were vexing us. We wanted to get rid of them because we want to be able to divide out that h on the bottom. Okay? Now let's see what we've got left. We've got 3 times x plus 4 minus 3 times x plus h plus 4. All over this mess on the bottom. There. Okay. Now, we carefully clear the parentheses and see what cancels. Okay. We got 3x minus 3h minus 12. It looks like some things cancel, right? The 3x, the 12, and I've just got negative 3h up top, which everything else is gone, so this h will cancel. With the bottom, it will divide. And now we're pretty much finished. Let's just rewrite it now. We've got this. We've got negative 3 over x plus 4, x plus h plus 4. There. That's it. Okay, so let's look at these ones. So a lot of this is just notation. We're saying, okay, what does f plus g of x mean? Well, it's just a shortcut way of writing. This one. It's just a shortcut way of saying f of x plus g of x. So this is going to be 3x minus 1 plus x squared plus 1. And if we could rewrite this as x squared plus 3x. Because the 1's get rid of each other. Now the next one, we've got f minus g of x. And anytime you're dealing with negatives or minus, you got to be careful because there's a potential to make a mistake. So here's what we've got here. We've got 3x minus 1 minus, now the tendency is just to do this. No, don't do that. No, don't forget, you're subtracting the whole thing. Subtracting the whole thing. Because, see what happens here. You got 3x minus 1 minus x squared minus 1. So, you could rewrite that as negative x squared plus 3x minus 2. You just don't want to forget that parentheses. So this is easy stuff, but there's lots of opportunities to make an error. Okay, now in this one, we're going to just multiply. We've got 3x minus 1 times x squared plus 1. You just distribute. And then distribute the negative 1. Yeah, like that. You could rearrange them if you want, but I'll just leave it like that. Okay, how's that? Any questions? Now we've got f over g, so that's 3x minus 1 over x squared plus 1. And that's really all we need to do with it. You could say, well, what about the domain? Normally when we have a variable in the denominator, we're concerned about the domain. But notice this is x squared plus 1. There's nothing can make that 0. Right? You can't add a positive number to 1 and get 0, ever. You'd have to add a negative 1 to 1 to get 0. But this is x squared. Any number you put in there, any real number, you square it and you get a positive. So this domain is just all real numbers. Or you could say negative infinity to infinity. Whatever suits you. Now, on this one, composite function. The outside function is f, so we've got 3 blank minus 1. And inside this blank is x squared plus 1. Yeah, and we could finish it off. Start this. Okay, now, so we're given a function up here. This is f of x, this function right here. And notice, what I'm going to do is I'm just going to take note of some key points here. I'm going to take note of this negative 2, 4, 2, 0, and 4, 2. Now, I won't always need to refer to these points. I just take note of them in case I find them beneficial to look at. So I took note of these key points. And I'm looking down here and it says, okay, f of x minus 2. If it's on the outside, if it's not inside the parentheses with the x, you do exactly what it says to the y. So for example, if you consider these points, this would be negative 2 and 2. I'm subtracting 2 from everything. See, these would be the points on this transformed function, right? Now, if you can just eyeball it here too. See, I'm just taking 2 away, and then I can do a little sketch. There's what it looks like. And you can verify, yeah, these points, they work. If it's on the outside, you do exactly what it says to the y's. If it's on the inside, you do the opposite to the x's. So let's look at this one. This one is f of x minus 1. That means everything is moved to the right 1 unit. So if you look at this, it's going to look something like that. In other words, all these x's have 1 added to them. Yeah, like that. Okay. Now this one over here, this one is on the outside. We've got 1/4 f of x. This is actually going to change the shape of the graph. The first one we looked at, A and B, those were rigid transformations. They just pick the graph up and move it. This one actually changes the shape. So it's on the outside. So what we do, the x's don't change. However, all the y's are multiplied by 1/4. We do exactly what it says to the y's. So this becomes a 1, 0, and 1/2. There. Those right there are the points, the transformed points. Negative 2, 4 becomes negative 2, 1, 2, 0, 2, 0, and 4, 2 becomes 4, 1/2. Because 1/4 of 2 is 1/2. Okay, so let me just plot these. I've got negative 2, 1 right there. 2, 0, that stays. That's easy. 4 and 1/2, 4, so flattens it out, right? Flattens it out a little bit. Okay. Okay, now on this one, the 2 is inside. We're going to do the opposite to the x's. So if you look back, we've got 4, 0, 2 for the y's. And what do we got? We've got negative 2, 2, 4. Okay. This 2 down inside here means we're going to divide each one of these by 2. Okay. So now we've got negative 1, 4. Okay, see negative 1, 4. We've got 1, 0. And we've got 2, 2. 2, 2. Okay, so here we've got this transformation. Now, remember, we're looking at this graph up here. This is the f of x. And what we want to do is we want to determine what the transformation is. And I went ahead and I've got it down here as well. But we want to know, well, what happens to this graph when I put a negative out front and a negative on the inside? So instead of f of x, I've got negative f of negative x. Now, one of the things that might help us on this is to look at these key points. Okay? So we've got the point negative 2, 4. We've got the point 2, 0. And then we've got 4, 2. Those are those key points. And I'm just going to take note of what happens to those, and then since this is just 2 lines, I can do a sketch. Well, we've got 2 things going on. We've got a negative on the outside, which tells us I've got to change the signs of all the y's. And then I've got a negative on the inside. Means I've got to change the signs of all the x's. So let's see what that looks like. Let's see what our points are going to be. Okay, so we've got 2, -4. We've got -2, 0, and -4, -2. So all I did was I took these original points that are on the graph and I've changed the signs because I've got a negative out front and a negative on the inside. Now let me plot these points. I've got 2, -4. I guess no, that's -3, isn't it? Let me see here. -4. 1, 2, 3, 4. I guess it's right there. And then 2, 0. Oh, wait a minute. I'm sorry. No, it's -2, 4. No, wait, I was looking at the wrong thing. I'm sorry. 2 negative. Yeah, I was right. 1, 2, 3, 4. Sorry. And then -2, 0. I have two sets of points here. I was looking at the wrong thing. And -4, -2. So I think it looks something like that. It's helpful, to see what's going on with the points and plot the points sometimes when you have these flippings going on, right? Okay, so there's what the transformation looks like. Okay. Now, let's look at this next one. On this next one, I'm moving to the left 2 and down 3. So let's think about this point. Let's just think about these points here. This point right here is going to the left 2 and then down 1, 2, 3. So it's going to be moved like that. Every point's going to move to the left 2 and down 3. So let's see what that's going to look like. I've got a point there. This one I move over 2 and down 3. See? So I move over 2 and down 3. Over 2 and down 3. Yeah, so looks like this. Okay, now instead of just having a generic function like we had, just those two lines moving it around, now we've got a situation like this where we have a parent function involved, right? We've got the absolute value function. So something's going to be done to that absolute value function. Now, remember, the absolute value function, it's just like a V. Just comes up like this. There's the absolute value function. So sometimes it helps to go ahead and just do a sketch of the parent function, and that will help us, in our final sketch. So here's what's going to happen. I'm just going to take note of this 0, 0. And I'm going to move that one as I need to, and then I'll just make the graph from there. So this is shifted down 3. That means that 0, 0 is going to come down 1. So it comes down to right there. See? And then from there I sketch my graph. Just like I sketched this parent function from the vertex down here, I'm going to sketch this one, the same way. See? There it goes. Just like that. And there's our sketch. So we look to recognize the parent function, and then we go from there. Now it's the same thing over here. I've got the parent function, absolute value. And then I say, okay, this has been shifted 4 places to the right. So this 0 becomes 4. And then I just make my sketch. Uh-oh. Got a little sloppy there. Yeah. There. Okay. So we look for the parent function and then we go from there. Okay, so on this one, we immediately see, okay, the parent function is the square root. And we have these parent functions in our mind. We know what they look like. We know the basic sketch of those. And I'll try to, make this something like that. Okay. I kind of regret putting the grids on here because I don't want us to get too bogged down and make it exactly right, because that's too much. But just to know the basic shape and how it's been moved around. Now this one is being moved to the right. See, because inside the square root is the -2. So we're moved to the right. And then we're shifted up 3. So let's see how that works. So this one is going 2 to the right and up 3. Yeah, right there. Okay. Okay. So and then we just try to do a little sketch. I will try to get it. I guess it's gonna something like that. Yeah, there you go. Something like that. Okay. Not a very good drawer, but everybody sees the idea, right? Okay. To the right 2 and up 3. Okay. Now, down here, so this one's got a minus. Now, we've got a horizontal shift and a vertical shift, but then we've got the negative in front. That tells us that whenever we draw this graph, we're going to draw it upside down. So look, if I look at this function, let me just draw part of it. There is part of, that's kind of what the square root function is. But with the minus in front, it flips everything down. So so you flip it. Okay, so I flipped it, and then I do the rigid transformations. Actually, this just flipped it upside down. So, in other words, the negative in front, I take care of that first. And now let's see what's going to happen. I'm going to move to the left 2. Whoops. To the left 2 and down 4. Right there. So now I'm going to, go like this, something like that. Oh, this up here, this V shape, I was just doing the flip. See, I did the upside down. So we've got 2 things. We've got the square root, the minus in front flips it, and then I moved it to the left 2 and down 4. But sometimes there's this question. We've got 2 things going on. We've got, which do we do first? And I just tell students, well, just get in the habit of, taking care of what's in front first. Okay? That's why I flipped it before I moved it. Sort of like the order of operations. Take care of the multiplication first. Okay. Now you can see the parent function is the squared function. It's a parabola, right? So if we look at this one, we've got something like just do a rough sketch. Okay, now we're moving it to the right 2 and down 3. So I think of the vertex. I'm going to the right 2 and down 3. There it is. That's where I want to make my vertex now. Oh, it's up 3. It's up 3, isn't it? Ah, man, thank you. So I go over 2 and up 3. There it is. Well, I have x minus 2 squared. Is that what you're asking? That just tells me what the parent function is. And the minus 2 means I shift it to the right 2. Okay, so let me... Whoops, up here. So kind of goes up here like this. Something like that. Okay, just some rough sketching. The idea is, what do these transformations do? And I don't want to get too bogged down in, plotting exact points or anything like that. We're just trying to figure out, well, what do these transformations do? Okay, let's see how we would deal with these. We want to write an equation, a function for each of these graphs. Now, the first thing we want to look and recognize what the parent function is. And this one, well, it's pretty obvious. It's a v. It's going to be the absolute value. Okay, so let's think about what that's going to look like. We're going to have the absolute value, and then maybe a vertical shift, but we have the absolute value of something. Now, it's right side up, so that tells us that we're going to have a plus in front of it. It's not going to be minus. And it looks like it's just been shifted rigidly, right? 2 units to the right. So x minus 2, that takes care of the horizontal. And then 1 unit up, right? 1 unit up. Yeah, so there we have it. And notice, we don't think it's been compressed or stretched or anything, because notice that it's just going, the slope is 1. See, it's just like the regular absolute value. It doesn't look like it's been, made steeper or flat or anything. So we don't have to worry about multiplying by anything. Okay. Now let's look at the next one. Also an absolute value. This is also an absolute value function. However, with this one, it's been flipped. This is upside down. Okay? It normally has a vertex at 0, but not this one. This one's been shifted over 2 to the right and up 1. Okay? Okay? Any questions about that? Okay. Now, square root. This looks like a square root function. And it normally would start down here at 0, 0, but not this one. This one goes over 1 and up 2. So it looks like this is going to be x minus 2 plus 1. No, plus 2. No. Sorry, I got them backwards. X minus 2 plus 1, right? No, did I do it again? Hey, what's wrong? What's going on? X minus 1, I have to be calm, plus 2. I lost control. Woo. Okay. Does everybody see that? You've got the square root function, and then you just move it over and up. And you can check to see, well, has it been made compressed or anything. And you look, and it's consistent. Like if you go to this point right here, well, let's see here. No, the scale's off a little bit. You could test it out and see. Make sure it's correct. You know, you could plug in a 2, for example, and you should get out a 3. So if I put in a 2 in here for x, square root of 2 minus 1 is 1. 1 plus 2 is 3. So yeah, it matches, right? So you could put in a point and make sure you got the right graph or the right function. Okay, what about this one? That one looks just like that other one, except it's been flipped. So this one is going to be negative x minus 1 plus 2. See, we just flipped it. That's the difference. Okay? Everybody see that? Okay, here we have, it's obviously just an x squared function. Now, for the x squared function, normally we have the vertex over here at 0, 0. That's normally our vertex. However, this vertex is down here. Now, you might, if you look up here, you can see what the scale is. So this is 1, and this is 2. So this is negative 1 right here. I guess I could have done a better job of making clear what the scale was. But if you look up there, you can see that on the y, every 2 is 1. Okay. So this is going to be a square function, and it looks like we're shifted 3 places to the left. Does that look like that? See? We come over here 3 places. And then down 1. Yeah, that's it. Okay? So that's just a rigid shift. Okay, let's look at this one. Once again, it's a square function, but it's upside down. So I'm just going to put a negative in front there, and then just look at the shifts. So what happened to this 0, 0? Well, it's gone over to here and then up here. So let's see here. That's 1, 2, 3. So it's gone to the right 3. And then it goes up 2. Like that. Now this one, cube. See? So we recognize that as a cube function. And it's been shifted to the right 1 and up 1. There. That's it.